morning guys, just a quick update in this video presentation. So just a reminder of the two key things you're working on this week. So the first off is the completion of the object-oriented programming course through Udemy. The second thing, which is due in on Friday, is an outline of your year 2 project as per all the resources that have been previously supplied. So that's for Friday. Just to kick off, we'll have a look at the answers to the exam questions on Boolean algebra that you did submitted by the end of yesterday. So I've looked through a number of your submissions and we seem to be pretty confident. So on the first set, which was just basically knowing those rules for the most part and confirming 3 of them, these were your answers, and I think by and large pretty much everyone got all of those correct, which is great. So nice simple marks, but important that you're getting them. So they're the 3 marks on that particular question. And then on this particular Boolean expression, which they then ask you to solve, again, most of you able to do this successfully, which is great to see. So in step 1, we've got the application, chance to throw in De Morgan's law, haven't we, over on this side of the expression. If I just grab the pen, so the application of De Morgan's here, okay, which results in this, to get rid of those overhanging not bars. And then this was the tricky bit, I thought, this next step, which I'd accidentally revealed, this next step here, because you don't apply this rule so often, but if you look at what goes on here, we can simplify that further. The reason being that we have, and if you remember from the actual from your notes on Boolean algebra, we can actually factorize this because we're meeting this condition here. The same term appears on in both expressions on both sides of the OR operator, and so it can be factorized. In this case, the expression, the term that appears on both sides is b, so we can factorize that, and that's quite handy in this particular instance, because what are we left with here? Well, a and not a, which means that we can simplify that again to 1, and then we know b and 1 is always just going to be equal to b. Okay, but the key, I think the key to this question was recognizing that you could use the factorization, and just remember that key rule for doing so. Okay, but a lot of you, I think, have managed to successfully do that. So we'll probably do another Boolean algebra piece of practice, but next week. Okay, I think you've got enough on the place with the object-oriented programming and the project proposal for this week to worry about. Okay, there's the mark scheme as well, so you can see that broken down. Okay, right, tab on. So the object-oriented programming course that you're working through on Udemy sort of divides into 2 parts. The first part really is the tutor guiding you through setting up a class, initiating a class, and a range of skills around the basics of OO programming. So do follow along with him and do experiment as you do in Visual Studio. As I just like to remind as well, good idea to maybe make notes as you're watching these tutorials as well. Some useful keyboard shortcuts and things like that they all cover, which are worth remembering, so do hold on to that. And remember, the whole point for us looking at this new sort of programming paradigm is that it features in the year 2 syllabus quite heavily, and also as part of your projects, your year 2 projects, and being able to show a high level of programming skill using object-oriented programming is one of the ways by which you can access those higher marks. Okay, so we're beginning to lay the foundation for that by completing the tutorial. Okay, so just going to talk about a couple of key concepts which hopefully you're beginning to get some understanding of from the videos and the tutorials in the course, but just key things that you want to focus on from the A-level point of view. So the first idea behind object-oriented programming is this idea of a class, which I'll just highlight on this side of the diagram. So we have a class, and I'll come back and talk a little bit about the definition of a class. But if you just look at the key kind of breakdown of a class as well, let's see if I can get a better pen. We've got a set of variables at the top of the class, and then a set of methods or behaviors or procedures, or whatever you want to call them, in the bottom side of the class. And then from that we can make objects, which are basically instances of the class. Now let's sort of try and make a little bit more sense of that, and begin to put a bit of meat on the bone in terms of understanding there. So let's have a look at these definitions in a little bit more detail. So starting with this idea of a class and with some code. So the class basically is a pattern or template that defines the fields, or another word for fields we might use is attributes, or in this case we've got the use of the word states, and the methods or the functions that can act on these fields, or in this case the behaviors. Okay, so you have to think of the class as being a template, like a template, and the template is composed of two key things really. It is the attributes and the methods. Okay, from that template that you create, you then can create different objects. You can initialize objects based on that template. Okay, so in this instance we have a class that represents a student, and from that class we can create instances or objects of a student. Okay, and you can see that each of these are different objects or instances of the student class. Okay, the student class being this template here. To actually create an instance and to create one of these objects, so to create an object from a class, we need to use a constructor, which is a method that sits within a class, within a class template. So you might put it under behaviors perhaps, or under the methods part, but the class will have a constructor which allows you to then create objects from it. And now this is something that you're sort of familiar with doing. Now in this particular class, if we have a look at the template up here and a bit of code, so you can sort of see this idea of this structure appearing again. At the top here we've got the class student. At the top of the class we've got our attributes, our properties for that class, and then here we have all our methods that determine what we can do with those attributes and how those attributes are manipulated. Okay, but you also see that the first method in the class is a constructor. Now in the videos he creates these constructors in a slightly different way. That's absolutely fine. In fact, normal convention is just to name them after the class itself. Okay, the constructor of the class, and you can see you can call the constructor then in your main program. So what you'll be seeing in the videos quite a lot is then he goes back to the main program and he creates an object. So let's say, for example, in this case, student is an object by calling the constructor for that particular class. Okay, so when you're calling new student, it's calling the constructor that's defined in that class. Now these two code segments don't actually match up, because you can see actually if I was trying to call and create a new object called student in this instance, actually I would need to supply some arguments into this particular constructor, because we can see here it actually takes in two arguments, the first name and the last name. Okay, I could potentially create a new student with absolutely nothing in the constructor, but the problem is then I've got to go through this process of assigning each of the individual attributes a value, which is going to take me quite a long time. Okay, but the key thing here that I think I really just want to get across, I'm going to come back to that a little bit later in terms of why having the constructor in this format is quite handy and quite useful and quite convenient, although I think you're beginning to see a little bit now anyway, is that student there, so student, we could say is our first object. If I circle over here, so we've made an object. Now obviously I could write out that same statement again. I could rename the name of my object perhaps to student 1, and I could create another new student, and that could be student number 2. Can you see how this template, if I go back over here, so this template is being used to create objects, and that's what the class is. The class is the template and the object is the instance of the class once it's been created. Okay, so lots of lines on the screen there, but really trying to get that core concept sort of embedded. Okay, and then I can interact with these attributes up here using the methods within the class. And you'll see that actually when you're working through this tutorial, sometimes he's declaring well, actually it's really good practice to generally declare these variables as private, and then you control the access to those variables and the modification of those variable values using the public methods that are made available in the class. So that's something you'll get more experience with, but that's a sort of security element really, and good practice element really, to allow only variables to be updated within the class by its public methods. Okay, just so you can see the same idea, but maybe a little bit more clear. So this idea, this time we've got a class of a car, so the entire class highlighted here. At the top of the class we can see the format again, so for this template format appearing. So if I just sort of draw a line through the middle here, in terms of we've got our attributes that describe the class declared here. Again, I would say that this isn't particularly good practice, so often they should be declared private really. Okay, but in this particular example they've declared them public, but generally they'll be declared private. So we've got our attributes at the top in this class. Where's my cursor gone? Oh, it's over there. Okay, so the attributes at the top, and then here we have our methods, and our first method, of course, and a bit following the convention a little bit more closely this time, is named directly after the class itself. Okay, and you can see that if we want to make a new object of a car, then when we call this constructor, we have to supply 3 arguments. Okay, now you can see that going on over here. If I just grab a pen, and you can see there we've got the class, so we're defining the class. There we're giving our object a name, so in this case we want to create a blue car, and then here we're going to create a new car by supplying those values into it, and we can then refer to that as the blue car in our program from then on, if we want to manipulate and get it to exhibit some of the behaviors that are declared in these public functions down here. Okay, and you can see they've basically done that 3 times, and we have 3 different instances, 3 different objects in this particular program. Okay, the important thing, they're all based on that one template. Okay, so very, very reusable and efficient is one of the things that maybe this is beginning to get across to you. Okay, one of the things which should be good for you to get some understanding of is the word keyword static as well, so look out for that, see if you can gain some understanding of that, and also switch on to the fact that actually you have used classes without knowing it really before. This isn't new really, this process of creating a new object. So when you start thinking about this, it's kind of been embedded in a lot of the programming you've already done. Okay, and the final thing I just wanted to talk about is that constructor again, and you can see 2 examples here. So here we've got a class car, and we're creating a new instance of the class, a new object called Ford, and in this case the constructor doesn't take any arguments. But you can see that's a bit faffy, because obviously once you've made the Ford object, it doesn't actually have any values assigned to its properties, and so in this instance we then have to manually go through one at a time and assign a value to each individual property within that class, and that's going to take some time. And it's the same thing here as well, isn't it? So for every car you create, you have to go through this process, which isn't particularly efficient. Compare it to this side, and you can see actually this is a far more efficient way of being able to create the same instances of the car class. Okay, so there's a key thing there. So basic concepts there, which I'm just trying to kind of embed. The idea of the class being the template, being able to create objects based on that template, and then the structure of a class in terms of its behaviors or methods, and at the top of the class its attributes. Okay, so just a little bit of insight there to help you along the way.